Hey everyone, welcome to my channel. If you're new to this channel, kindly subscribe and hit that notification button to always get my updates. In this tutorial, we'll talk about lists. How we'll look at how we can create a list, how we can measure the length of a list, how we can add different items to a list, how we can access different items in the list, how we can perform negative indexing, how we can use the functions like append, extend, remove, insert, pop, and so on. We'll also look at how we can do slicing of a list. So if you are new to this channel, kindly subscribe and hit that notification button to always get my updates. We'll bring you all the videos in regards to beginners tutorial. So let's get started. Alright, so this is going to be entirely on lists, and maybe some last part will be on strings, but let's get started with the lists. Alright, so let's create a list. A list is created by two square brackets, and then we can choose our items. Maybe for the moment, let's have 1 2 3 5. Alright, so if we first of all check the type of this object L, we'll see that it will tell us that this is a list. Alright, so let's begin. Any list is created by two square brackets and then populating those brackets with elements or terms separated by commas. It doesn't matter what is here. For example, L can be, or let's say P can be a correction of 1, maybe some elements which is in terms of string, and then maybe E, and maybe it can be a float number 0.4, and so on. Alright, so this means that a list can take on everything. Again, just to make sure that we are safe, let's check again the type of P. If we do that, it will tell us this is a string. Alright, so let's focus on list L. So how do we, now that we know how we can create a list, alright, so we can make this, we can make a comment here that we create a list by using square brackets. Alright, so now that we know this, let's try to go on by looking at how we can measure the length of a list. To measure the length of a list, we'll use a Python built-in function, which is len for length. So we can say length of L, and then if we do that, that will give us 4. Right, remember Python measures the number of elements. For example, if you go to list L, this is 1 2 3 and 4. Alright, so that's how we can tell the length of any given object or length list or whatever. Alright, so let's try to see how do we add elements to a list. We can add elements to a list or change elements in a list in several ways. Alright, so let's see how we can access different elements within a list, and we'll also look at how we can create multidimensional lists. But basically, let's first see how we can access different elements within the list. Let's say we want to access an element in the third position. Just to remind you a bit, Python begins counting from 0, so this is 0 1 2. Alright, so if we want to access the third element, we'll simply say use square brackets and have element in position number 3 indicated by 2. Remember, it begins counting from 0 1 and then 2. If you try to run this, it will tell us this is 3, so which is exactly what we have here. So this is basically how you can access different elements in within a list. But let's suppose we want to print out different all the elements one by one. Then we can make a use of a for loop. For example, for I in list L, alright, and then we can say print I. So this prints all the elements one by one in list L as 1 2 3 and then 5. Alright, so that's how we can, and actually to make this more we can, for example, in the previous video we looked at how we can deal with different elements like squaring them, dividing them, and so on with different operations. Let's try to take a square of all these numbers in the list. We can then power them by 2, alright, and then if I print that, that will give us 1, 2, 9, and then 25. So in the same way, I can print that, say, in the table, and then I begin with a print up here. I can say, first of all, let's print some headings, and we will say this is element I, alright, or small I, and then we'll have the squared numbers, squared elements, which we have as I squared. Alright, so when you have these two, I can split these two to create a gap here by using a command which we know as backslash and then T. This creates a space, or what we call a tab, in between these two titles. So when I come down, remember I have to print I first and then the squared elements. So I'll first of all print I, then because I need the same space within those two elements, then I can have a backslash and then T, alright, and then print my I squared. So if I do that and print that again, it will give me like this. So I can as well include in more space here, just to make it to fit a little bit down there, just like that. So this means that these are the elements of I, and then these are our squares. Let's see another way of accessing these numbers and their respective positions. Alright, so I'll just go up here and then make a copy of that, and then we need to look at how we can print out each individual elements in this list L and its respective position. Remember, Python begins counting from 0, 1, 2, 3, but again it stops on one number less. Alright, so let's say for I in range, now we are looking at I as a position like 0, 1, 2, and then 3. So I'll say range of length of L, right? The reason why I'm taking just L is because I know Python is going the length of L, we know that it's already 4, alright, and then how many times terms we have 4 terms, so Python will begin from 0, 1, 2, and 3, alright, and then when we present it like this, length L is 4, but you know Python will be counting up to just 3, alright, which makes sense. So let's go further and print out our I, which is the position, and then we'll print out the position, I mean the number that corresponds to that position, as Li. If I run this, then I'll have that our position is that. Then I can still do the same thing and have first of all some titles up here, and I can say print element position. Okay, I can say position, alright, and then the element itself. Okay, so this means that I have L, alright. So if I do that, and I need to create some space in between here, that will give me backslash T. Alright, like two tabs will create enough space. So basically this is what we see: element position and then the elements itself. So this is how we can play along with that. And then so now let's try to move on to the negative indexing. What does negative indexing mean? Negative indexing, let's see what it means when we talk about negative indexing. Let's say you want to look at the terms from its end position. All right, so let's say if we say L equals -1. What does this mean? When we use a minus index, Python looks at negative indexes as from the end towards the beginning of the list. For example, in this list, which begins from 1, 2, 3, 5, it considers as the first term when you are in terms of negative indexing as -1. So its initial position is -1, -2, -3, and then -4. All right, so which is different from when we begin counting from the beginning, where it begins from 0. All right, so if I print that, you can see that it calls it calls 5. So if I create, so that means in that case, if we call -4, this will call the first term, which is 1. Alright, so this is what we refer to as minus indexing. We will look at more of this when it comes to slicing. Alright, so let's now go ahead and look at what happens if we want to add more terms to that element. Alright, so there are so many ways how we can do that, and one of them is when we use a function that is called append. Append, what simply append does, adds that particular list to the previous one, or that particular element to the previous one. So let's begin by creating another list, R, which we are calling -2, 0, and 10. All right, so this list, let's try to see what happens if we append it to the previous list L. So I'll try also to bring our previous list L right here, so that you can have all the two lists all together. So let's try to append the list R to L. So in that way, I'll simply say R dot append. Sorry, I want to append R to L, so I'll begin with L append R. So what is going to happen is that within list L, we are adding on list R, and so when we do that and we call back L, we will have something that looks like this. So try to look at the difference here. So if R is another list, this list is just added within a list, and so this creates some kind of multidimensional new list, which is L. All right, so how about if we just want to add on a number? All right, and in that case, I'll simply say L dot append maybe 20. I append that number to the previous list L. So if I call L back, that will give me this one. All right, so that's append and how we can look at append. But if we wanted, for example, to add one number by number on that list, let's say I'm adding on a certain range of numbers. In that case, I can say, for example, for J in range of that given number that I want to add, let's say 40 to 50. All right, and so this means that the numbers are going to begin running from 40 up to 49. So I'm going to say then we have our list L dot append. What am I appending on? I'm appending on J, which is each number within this range. We will say print L, and then let's see what happens. So when you look at this more clearly, before we had our L as this one. After appending on list R, we had this one, which stops actually here. Alright, and then finally we added on 20, which is here, and then now this for loop here adds on from 40 up to 49. So that is how you can add numbers by numbers in a list. Suppose I wanted to add on something like a tuple to a list. Let's say t equals 0, 2, 1, and this is a tuple. Well, we know that, we looked at that in the previous video. You can check out that video. And we say l dot append t. So when you run that and call back l, you'll see that it's added somewhere right here, just the way it is. So this tells you actually that a list can contain anything that you may put in can be accommodated within a list. So let's try to look at the extend function, which is another function that can use to alter the size of the list. All right, so if I'll take this one, then down here the list extend. All right, so let's have another fresh list. Let's try to call back r, which is -2, 0, and 10. Let's try to extend this list by using, say, x equals another smaller list, maybe to 3 and then 4, and then when we say r dot extend x, let's see what happens. If I call back r, that means this is just written down as it is. So let's look at the actual difference between append and extend right here. So as you can see, if you use extend, all the elements, even if x was just was another list, this list, what we all do is to have all the elements of that list and populate them within this list, which is different from append. If I say r dot append x, so let's see what happens. If I call back r, see what happens. The full list is just added on the list r. Alright, so this creates a very big distinction between append and extend. So if you don't want to have such, or in other words, if you don't want to have multidimensional lists, then the best function to use is the extend. Alright, so that means that gives you an idea. If you wanted to create maybe a matrix, you could manually do it that way. Before even we look at the functions that are used to create arrays, you can manually do it that way. For example, if you have another list, let's say of the same shape, say 3, 0, and then 1. All right, and then we say you have another list which is empty list, and then we come down here and say t dot append x. All right, and then we add all that, and then again we add on t dot append, although we can do that all together in either in a group, append y. Let's see what happens. What is t right now? This gives us what we could look at as a 2 by 3 matrix. All right, so this is how we can create also multidimensional lists. So let's try to move ahead after looking at the big difference between extend and append. Let's try to move forward with another function, which is remove. So how does remove perform or do its operation? So let's try to see how another function, the remove function within a list. Let's see how it works. Okay, so if remember, this was x, and then this was y. Alright, so I can set t and dot remove y, and if I do that and run, if I call back t, this will give me 2, 3, and then 4. And if I continue to do that the same way, so this tells you that let's say for the list which is r, which you created already up. Alright, so if you want to remove a certain number like 10, we can simply say r dot remove 10. Alright, and so this will give us a new list r that doesn't have 10. Alright, so this is how you can use the remove function. And then now we need to move to another function that is called insert. So what is insert function? Insert function in terms of list is a function that you can use to position any term anywhere in any position you need. So again, I'll call back my list r, which we used up, and then let's say in between, right here in between 2 and 3, we want to position there another element, let's say 5. All right, so that means we want to position it in the this is 0, 1, 2 in the third position. All right, so I can say that t dot insert, and this means we need to specify the position, that is the third position, and what's the element I need to position there, 5. So if I try to do that and then run r again, it will give me 5 as in that position. Again, even if we need to position there a simple list like that, then we can simply do the same thing and say r dot insert, we specify the position, maybe 2, and then you can create a simple list -1, -2, and then 0. If you run that and again call back r, that would give us this full simple list positioned in position 2. So I think this gives you a good understanding of the functions like index, append. We have done indexing, we have looked at extend, remove, and insert. Alright, so let's move on to the next part, which is the pop. What pop does is also kind of like remove, but the idea here is that if you don't specify the number, again it does remove the last term or element in a list automatically. So right here we have our r, which is the updated list. So let's say r dot pop up. Alright, so let's see what this will do. We expect that it's going to remove all these terms since it is considered as a full term. If I do that and run it again, this is what happens. Alright, so you can see that this is removed, and then our last term is now 4. So if I do that again, it will keep on removing the last term. That's how pop works. But let's say we don't want to by default remove the last number, but we need to specify the number we need to remove, and in that way, I mean, let's say we need to remove this number, maybe 2 right here. Alright, so how do we remove 2? Or if we want to remove this full element here, which is a smaller list within a list, in other words, this is what you call nested lists. So this list, which is nested within this bigger list, suppose we need to remove this, so you can look at pop beginning that this is -1, this is -2, and this is -3. So if I do that, I'll say r dot pop an element that is in the position of -3. If I do that, I'm removing out so if I call back r, this is what we get. Alright, so this exactly tells you here what it has been removed. It has been popped out, and then we have the balance right here. So which is another powerful function when you're trying to manipulate or downsize lists. So alright, so this is basically the pop function, and then right now let's look at what is meant by slicing. So slicing basically is kind of related to what we have already seen as indexing and so on, but in this case it's like you want to print out a certain size of quantity or size of something. Alright, not everything, which you can always access by print. If we say print maybe L, will print everything. Alright, but now let's say out of a certain list we need to print out a certain size of elements. So then that's what we call slicing. So we can slice that, we can slice our bread into some pieces, and we come up with the outcome. Alright, so let's go ahead and see what is slicing is by creating a new list. So we can say this is list of a certain range of numbers, maybe from 0 to maybe 40. Alright, so if we do that, and let's just try to print out L. Alright, so that will give us 0 up to 39. So that's what we need. But now let's say if we don't want to see all these numbers, if I say print L, alright, so let's see if we want to access some part of this list L, which goes from 0 up to 39. So let's say we need only 0 up to 10. Alright, so I'm going to say maybe my T1, the first tens, is equal to this list L, and then we need to include in all the first terms up to the 10th term. So have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so if we try to print that one out, so this will be T1. Let's see what we have. So it will be 0, 1, 2, 3, 4, 5, and so on 9. Alright, so that stops right here. So just because Python, you need to be extra careful. That's because Python always stops at one less. Alright, so that means we are taking on everything up to this other term less by 1. Alright, so let's see if we just needed in between here, maybe in some position here up to some position here. Let me just take an example, and I call this one T2. T2. So maybe I can begin from the 20th term up to maybe the 31st term. So again, we know that it will begin from 20 and it will stop around 30. So if I print that again, print T2, let's see what we have. Alright, so you can see we have another smaller list which is stopping at 30. So this is what we call slicing, and it is very useful that in such a way that you can reduce a bigger list and produce a smaller list. Alright, so how about if I want it to access from the end? So in that case, we can make a use of so far we have looked at getting almost from the first terms up to a certain number of terms, and then let's say if we want to get from a certain term, say T3 equals L, from a certain number and beyond, let's say from 40 no, 40 is not inclusive, from 20 and beyond up to 39. So this will give us all the terms from 20 up to 39. So if I go down here and print it correctly, T3 will give us 20 up to 29. So this is how we can slice off all numbers from 20 up to that. So if we wanted to perform a certain operation on that, that is how we could access that. And we have also seen how we can access in between numbers, let's say from 20th number up to 31st number. That's what we have. Remember, these are just positions. Alright, and then finally, if we want to reverse a list, we can do that by saying L reverse. Okay, so because I'm looking at L, so we have L, and then we have our initial list, and then -1. So this means that we are beginning from the end, which is 39, then we go until all other elements, until the last part. Alright, so if I do that and say print R reverse, so let's see what happens. We are beginning from 39 up to 0. So this is very important. Even if, so there are other functions in Python, for example, like reverse and so on, but those can work in other ways, but this, I look at this as being the easiest way how you can reverse this easily. Alright, so finally, let's look at how we can add lists. So now we have seen how we can perform different operations on lists, reversing the list, pop up, insert, remove, append, and so on. Let's see how we can add lists. So as we have already seen, let me create another variable here and call it total, and say equals, this is L plus L reverse. Alright, and say, let's say we print out total. Let's see what happens. Alright, so this, what happens is that we have the two lists added up. So that means we can add one list to the other and form a bigger list. So as you can see, this one goes up to, remember, it stops at 30 at 39. Alright, the first list, which is L, and then the L reverse begins actually from also 39. Alright, from here R reverse begins from 39 up to 0. So as you can see, the two lists have been added with even these terms all repeating, but in a reverse way. So lists can easily be added as simple as like that. Alright, so if you go on and check the length of this variable list, it will give us 80. Alright, so that's how we can treat, that means lists can be added or concatenated. Thank you guys for watching. If you haven't subscribed, subscribe for more tutorials, and hit that notification button to always get the updates from my channel.